Well, I'm trying to change the title of the stream on Twitch, but because Twitch is a web page, it doesn't work. And for me, it still says compiler profilin. I've tried to change it twice. Hopefully it's changed for other people out there. We'll start in a couple minutes. "50% of the time, it works every time." This is not Go Bananas that you see. This is a profiler. It's a different thing. It is not something that I wrote. It is a product from Rad Game Tools that we are licensing to be able to use it. If Go had memory management, there's lots of problems with Go. And what do you mean by memory management? It does have memory management. It's garbage collected. That's memory management. Okay. Let me get my tea ready, and we'll start in about a couple minutes. No GC. Well, I would have been more likely to use Go if it had no GC, but it doesn't actually solve a lot of the problems that I have. It just, Go not having GC would be not putting an extra problem in the way, which I would appreciate. But it doesn't solve most of the problems that I have, right? So, a lot of the things I'm doing here, like the metaprogramming and or the specific way we do metaprogramming, the elimination of build tools, the extreme amount of communication that your program is able to have with the outside world, and the extreme amount of introspection power, all those are things you don't get in Go. So, yeah. All right. Let me get my tea and then we'll start. Okay. Hi, everybody. Welcome back, for those of you who are back. It's been a long weekend of streaming, but we've got a ton of things done, and I've been having a good time doing it. So we're going to do a lot of streaming today as well. We might not do 11 hours like I did for the past couple of days. We'll have to see how it feels. I am not a professional streamer like Shroud or something, and doing 11 hours a day many days in a row maybe makes me a little tired. And of course, being too tired is not good for making quality code. Someone's asking, are you using the format label for GoTo labels? We don't have GoTo labels yet. We probably will need to add them, but we don't have them yet. And you're essentially asking a syntax question about, do we use colons for those labels? We probably would not. Yeah. Having GoTo labels have a terse syntax is not a very good idea. You want them to have, because they're very rare to use. So you want them to actually have a less terse syntax, because you want to reserve the terse syntax for things that are common, right? It's like data compression. If you want a good compression ratio on your data, you use the short bit sequences for things that are common and the long bit sequences for things that are rare, okay? So reserving a single identifier colon being a GoTo is a bad idea, because it takes that syntax away from things that are much more common and much more necessary. Am I a better programmer compared to 10 years ago? Yes. Will I be a better programmer 10 years from now? I hope so. I hope so. Okay. Last night, we did some profiling. And then I tried to do some optimization based on that profiling, and it worked functionally, but didn't speed up the program and made it more complicated, so then I deleted it. And this morning, I was thinking about, okay, what do I do with the information on this profile? Because there's a lot of areas, we're trying to speed up the front end of the compiler, and the front end takes about 500 milliseconds, and, 526 or something. Maybe that's not quite the right number, but it's in that neighborhood. Infer types takes over half that. And so one of my ideas was, well, I want to do this massive structural change on infer types, and that may speed that up, right? And my assumption had been that that was what I would try today. I feel like that's big enough and complicated enough that I wouldn't be able to do it in a day. But then, I was thinking some more about these things, and where is the polymorph stuff? Oh yeah, this polymorph do polymorph here. which we see that's what all these rectangles are, for example. This is a zoom in on this profile, so this is not, it's less of the time than it looks like if we're zoomed in specifically on that. But this is catching my eye because it's a little bit of a more isolated system, right? And it's actually hierarchically part of this expensive thing, right? So this 241 milliseconds has this 46 inside it. So it's like, it's already about 1/5 of this. So by optimizing this, I would be optimizing this. And this is one of the things that is still scary and too complicated. It's been scary and too complicated the whole time that it's existed, but I've been gradually simplifying it. And it's a lot better than it used to be, but it's still more complicated than it should be. And so I'm thinking that I would like to attack that. So I can give an overview of what do polymorph does and explain why it's a good idea to attack it. So if I go somewhere, great. People are moving stuff around on me. Okay. So here's some examples of some basic polymorph routines that you may have seen at various times. So, if you want to add something, if you want to add something to an array, you call something like this, and, well, let me get rid of the dots. You call something like this. And what this says is, well, there's an array, it's of some type T, and the array itself determines what that type is. And then whatever item you add has to be of the same type T, right? So array add has a body, okay? And the way that type inference works in this language structurally, just want to move this away from the left border of the screen. The way it works structurally is that when you call something like array add, we determine what T would be for your arguments. Well, I'll say now this is not exactly right, but we check to see if there's a version of array add that already exists for that type. If it doesn't exist, then we have to make a new one. And how do we make a new one? We copy the syntax tree for this whole procedure. And then there's an invisible scope up here called the constants block, which we saw lots of the other day, where we say T equals, well, it starts out, we don't know. In this version of the polymorphic routine lives off in space somewhere. It never gets compiled into actual code, but it's a data structure in memory, and T is bound to we don't know. But then if you give an array of int, we say, oh, T is int, and that lives in the constants block, right? So we copy a new version of this whole procedure. We put this assignment in the constants block, and then we do type inference and all this. And the reason we copied the procedure is that the nodes themselves contain the type information. And so you can't have multiple types on one node, so we copy the whole thing. Now, there's certain aspects about that are questionable. Like, for example, what if when we parse this, we keep the originally parsed version of the procedure body only, and put the types somewhere else, like in a parallel array, and then you don't need to copy the body? That could be a good idea. The problem with it is there's a number of things in the compiler right now that want to modify the syntax tree. For example, one thing that front ends of compilers often do is they look at one subtree and they transform it into another subtree. So if you're doing constant evaluation and someone says 3 plus 5, right, you might just turn that into 8 in the front end. And we don't actually clobber the original pointer, but because when when the user's metaprogram wants to introspect on this, we want them to see the original code of 3 plus 5. But there's like a substitution slot on that pointer that says 8, for example, right? And similarly to the type that we infer, that goes on the actual node. It's worth it. It's definitely worth it to think about changing the way that that happens. Because then polymorphing might get less expensive because we wouldn't copy the whole procedure. Maybe we only copy the header, or maybe we don't copy any of this and we just make a parallel array and a new constants block. So that is all an interesting question. But that's not my biggest problem right now, because whereas the copying is, takes time, it's not scary complicated. Whereas polymorphing causes copying to happen and takes time and is scary complicated. So if we hit polymorphing, we do a better job, right? So is there any question about this so far? Because I'm going to go into more complicated versions of this in a second. So I want to make sure people kind of get what's going on. Just get rid of polymorphic procedures. Well, it would certainly make the compiler a lot simpler to get rid of polymorphic procedures. But no. Okay, if you've got a question about this, type it to me while I say this next thing, right? So thing number one that I want to say next is I lied a second ago when I said first we look for procedures that that match, and then if they don't exist, then we do a copy. And the reason that's not true is the following. How do we compare two procedures? Well, we compare them by comparing the constants blocks, right? There could be multiple variables in here. There could be like an R is a type and S is array of 10 string or whatever. There could be 10 variables in here, right? N equals 4. There could be numbers, right? So when you want to say, hey, do we have a duplicate of this? Do we not need to generate code for this because we already have one? You want to compare everything in this constants block versus the constants blocks of all the versions of this procedure that you've already generated. How do you do that? Well, you've got to have a constants block. You've got to solve for these matches to know whether anything else matches. How do you solve for these matches? Well, the way it works right now is you do type checking on the header of the procedure, right? And you can have a modify proc in here that changes those, and that has to be able to run, right? And like I said, well, the place where this constants block gets stored right now is on a copy of this procedure, right? So actually, for every attempted polymorph, whether it already exists or not, we copy the procedure first, we solve for the matches, then we look for a duplicate. And if we find a duplicate, then we throw away the copy of the procedure, but we still take the time to copy that procedure, right? Okay, I don't see any questions toward me. So we'll keep going. Hopefully people are following along. Now, this is the simplest version of polymorphism. There are a couple of things that are more complicated. Okay, thing number one that's more complicated is nested polymorphic expressions. So if I go into old bugs, we had this example called nightmare, right? Where so this thing is polymorphic, right? So it's got an argument that's a pointer to some type, right? Let's just sort of say what the constants block here would be. it's got a variable called some type, right? Which we don't know what that is. Now, it looks like it has these other variables, r and k, but these actually belong to parameters, right? So there's a parameter. I'm just going to write the parameters explicitly. There's some parameter that's a procedure type, and it has a variable called k, right? There's some other parameter called y that is a different procedure that has a return type r that's polymorphic, right? And then the other part that makes this nightmare is these type ofs refer to other things. So you can't resolve this in order, right? If you're just trying to do f, or if you're trying to do x, and you're just waiting on this, then you're never going to get to z, right? So this has to be a multi-pass iterative solving, right? So, you know, I won't write r here because it doesn't introduce a new variable. Okay, so when this starts out, when we parse this procedure, we say, aha, this is a parameter of the procedure, right? But then we've got this, okay, but then there's the question of like, how do you do the matching, right? And the way I elected to do the matching way back when I implemented this was like, doing this nested thing, this nesting of a procedure can get arbitrarily complicated. Like this could have more polymorphic procedure arguments in there, and there could be polymorphic structs as arguments to those. And this could go arbitrarily deep, and that could get difficult. So what I'm going to do is do this thing called polymorphism steal, where every time you have an argument to a procedure, you look and see if it's polymorphic. And if it's polymorphic, you grab those variables and lift them up to the topmost thing. Right, so let's just put this down here for a minute. So we start out with only some type being a top level argument, but then we steal r and k, right? So we say, all right, well, k is also something and r is also something. So that's thing number one that makes this complicated. And, you know, this stealing process is just confusing to think about because the way that we do it, I mean, I don't even remember. It's simpler now than it used to be. But anyway, this is a process that has to happen. And if that didn't have to happen, that would be simpler. It's something that I definitely had an annoying time debugging when it was first being implemented. Thing number two that makes this complicated. Let's go back to our bucket array that we kept debugging a bunch these past few days. So when you have a procedure like this, right? This is different. Let's put a lot of space because this is different from the previous example. Okay, bucket array itself is a polymorphic struct, right? So this takes arguments, and we don't know what type this is until these arguments get filled in. You used to have to say this kind of thing in the header, right? You used to have to put all this, but then I said, oh, well, we're just going to let people do this as a shorthand, because if you have to do this, right, then it's a pain in the ass to edit your program. What if I come along someday and I want to say x is something, right? I don't know what. Then every single place that uses this, you have to like put another thing in here, right? That's a giant pain in the ass. So it just seemed good to say, look, if you use a polymorphic type like this, then you can just say the type and we'll implicitly convert it. So inside the compiler, when we see this, we say, aha, bucket array is a polymorphic struct. So we're going to insert this, right? So this is the version that the compiler makes and that the compiler sees. And this is the version that the user sees. Okay, so that sounds fine. Okay, so now in the constants block of this, we get A is we don't know and B is we don't know. These are really called, they're not actually called A and B, right? If you saw some of the streams, they would be called auto poly type 0 and auto poly items per bucket 0, because it helps me understand this and this. Now, here's where this gets more annoying and really hard to think about. The part about all this that I haven't said is that when you do this, or even when you do this, well, how does all this work? Because I've lifted these variables up into the topmost procedure. So when I do pattern matching on this procedure, I get all these matches for values for the top level procedure. And then they have to get back down somehow into here. And the way that works is I actually polymorph this thing. Not only do I make this auto poly parameterized thing, but then I invoke polymorph on it. Then I make a thing that says polymorph bucket array of, so let's call these A and B, just because it'll make the following thing I'm about to type shorter. I polymorph bucket array and say the slots here are type and items per bucket, where we say type equals A, items per bucket equals B. So we go through this whole polymorph process to make a whole entire copy of this type where this variable just refers to this constants block entry and this variable refers to that constants block entry. And then if the polymorph match succeeds, then we can like re-polymorph this type by filling in these things. Now this happens anytime you try to call a procedure. Let's say you have 10 overloads of find and occupy empty slot. Well, how do you know if you can call an overload? Well, you can call an overload if you can successfully match these variables. So we have to test if you can successfully match these variables, which means we do all this. Like if you're going to call an overload, even if this overload of the procedure is not the one that you're calling, we have to copy any of the polymorphic arguments. We have to instantiate their constants block. We have to do the type matching thing. And then if the type match fails, we throw all that away. And it's hard to think about. And there's complications. There's the constants block is more complicated than I would like it to be to think about, because there's like 3 things that can happen. There's this where it's like, hey, there's a variable and we haven't matched it yet. We don't know what it is. There's this, which is, here's a variable and it has a definite value. But then there's this, which is, the constants block for this version of bucket array is type equals A, whatever A is in our enclosing scope, and items per bucket equals B, right? So this case has to be differentiated from this case, and it's just hard to think about. Because this is still polymorphic, right? A and B might not be resolved yet. So this is polymorphic and this is polymorphic, but they're polymorphic in different ways, which is a pain in the butt. So all that happens, it's complicated and it takes time. So The reason I'm saying all this, I mean, first of all, people ask me about this sometimes. So I wanted to say all that. But secondly, I can do a very early experiment, which is this kind of polymorphing where we just polymorph to make variables. I don't know what percentage of these polymorphs that is, right? So whatever percentage that is probably tells me roughly how much of this time that takes. But also, it's not just do polymorph, right? We do copies here to make this happen, like I was saying. So the copying, I don't know where copying is in here. Can I search this? Copy. No, we're not instrumenting copy for polymorph right now. So it's unknown. Maybe we should do that. Instrument copy for polymorph. So then the other thing, so, you know, when we have to do these copies, it also adds complexity because, you know, when you've copied something, that copy needs to have its type inferred again, right? And the type, for some whatever random reason, may not be ready to be inferred. So you might have to yield, right? So like all this yielding that we have to do gets more intense in these situations and more complicated. And so what I want to do is try doing this in a way that simplifies all of this, right? So the thing that I want to do to simplify it is the following. Instead of doing this steal up to the top, and instead of making this copy, and instead of making this autopoly, I don't want to do any of that stuff. Instead, I want to leave it like this, because we know bucket array is polymorphic, so we know this procedure is polymorphic. That part is all fine. When we try to call this and we do matching, instead of trying to steal the variables all up to the top, I want to have a more complex data structure that just tells me where they are. So here, I want to have, instead of putting the, let me go way down so for clarity, instead of insisting on putting all my matches in the constants block of this at the top level, I want to instead say argument 0 type equals something, right? And argument 1 items per bucket equals something, right? 10, because these would be concrete values, right? Now, the slight trick is this is not so easy because of this nightmare case, right? In this case, the arguments have arguments, right? So here we would have, for example, argument 0's argument 1, k equals float, right? And then argument 1's, let's just call this argument 2, even though it's the return value, right? But we don't want to have to complicate this data structure more than we have to. R equals, vector 3, argument 2, only one level here, right? Sum type equals array of 10 S8s, right? So we would end up with a more complex data structure, which is the thing that sounded complicated. But I think in the end, it'll be much simpler. And we can get rid of the autopoly thing in that case, I think. And we can get rid of, so here's the thing. Once we have this, right, we didn't need to generate a new constants block to do this. This is just our matching schema. I mean, that's, yeah. This is just goes in the array of like how we matched things. we don't have to put it in the constants block yet. So if we save this when we polymorph, we can check to see if this already matches someone else. Regardless of whether we've done the copy yet or not. That's actually that will take more work because all this stuff that I've been saying presumes that the only way that you can get an instantiated or a concrete version of a polymorphic thing is by procedure calling, but there's other ways, right? So you could like bake one argument and then still have a polymorphic procedure that other people call and whatever. So these can get filled in different orders, and you would have to, do the compare in such a way that you don't get fooled by that. Anyway, that is what I'm thinking I want to do. I'm hoping it would be less complicated. It's a scary thing to do. I don't know if I can do it today, but that's fine. Because polymorphism gets used a lot, and the simpler it is, the better it's going to be, right? Ginger Bill is saying, why not make the polymorphic parameter explicit rather than implicit, e.g. $t/bucket array or $t/bucket array AB? Wouldn't this simplify the problem you're having to begin with? It wouldn't really change anything at all. It would cause that problem I was saying before. The paren $A $B version does introduce the problem that it's more of a pain in the butt to edit your code anytime you change a polymorphic type to have a different number of parameters. And I want to avoid that, right? That's one of the stinky things about C++ and some other languages as well, is that you start using templates in C++, and now everything becomes different and everything becomes a headache. And I want to avoid that because I want to make these easy and nice to use, right? So I don't want to impose an extra burden on the user in order to make my job easier here. My job is to do good things for the user. Is there a risk of if two of Nightmare's parameters both have internal $T parameters with the same name, which might bind to different things? In the current way I am doing it, yes. Actually, I have a note in the code that's like, because I'm using the names to do the matching, even though I'm supposedly mangling them, I don't really mangle them enough, and they're not unique, and you can certainly cause a situation where you get a conflict. None of our test cases do that, and I was just kicking that can down the road, but this would fix that because this just says exactly where these things go, right? Now it's interesting because this changes the way that I would instantiate a polymorphic type, right? What you would end up doing is some kind of thing where you go down to the deepest level of argument and we say, okay, argument 1, let's get that type and copy it and instantiate it for k equals float, right? Okay, now argument 2, let's get that and copy it and instantiate that. It would make more sense what I'm saying if this went down to more levels, but you basically have to go from the deepest level to the shallowest level when doing this. Are the array types boiled down to polymorphic structs in the internals of the compiler, or are they a separate thing? They are a separate thing. They are not by default polymorphic unless you declare a polymorphic one. What happens if two functions have the same name and parameter, e.g. your own code and library code? Well, if they're in different namespaces, it's fine. If you try to pull both of those into the same namespace, it will complain to you that you can't do that because it wouldn't ever know which one you're trying to call. Wow, that was a lot of talking. How much uptime do we have? 42 minutes. Wow, that was probably like a half an hour of explaining. Well, this will be a good place to point people at. There's other explanations of polymorphism on YouTube. How about operator overloading? Operator overloading just turns into procedure calls. So all of this that I just said is the same for operator overloading. That's just a layer on top of procedure calls. So the first thing I want to do, and who knows how much past this we'll get in this first stream. I'm going to be taking lots of breaks today because, like I said, it's like day 4 of doing a lot of streaming. I just want to know how many of these 3,121 do polymorphs are autopolys, right? And how many are not? Because if it's like 10 autopolys, then maybe I'm less motivated. I'm less motivated to get rid of it by performance, but more by complexity still. But I just want to know. I want to, because this is going to be hard to do, and it's going to break. When you break polymorphism in this compiler, it's a bummer because like nothing works for a long time and it's a drag. This is one of those things that you have to psychologically prep yourself because it's going to be a hard time. You don't, I do, right? Because I have to get this done and make it work again. And it's all like the compiler works so well right now. We just got our bug count down to 0 of actual filed bugs. I mean, there's probably actually bugs in there still, right? And so to go from that to like, now I'm going to make a giant mess and nothing's going to work again for a while is a bummer. But it's what you have to do to make good software, right? And this is the kind of thing I wish more people would do, okay? This whole polymorphism scheme that I mentioned works with the exception of that name conflict that somebody asked about, which could be, you could just pile more code on there to take care of that and, quote, solve, unquote, it that way. But it's better to make the software better. So that's where I'm at right now. I would call this more than just refactoring. Like, it's definitely refactoring, but it's a refactoring, it's a replacement of a core system by something that works in a different way. And that is a refactoring, but it's a serious refactor. It's like being a bull in a china shop. Sometimes you got to be the bull in the china shop, and that's who we're going to be today. We're going to fuck shit up real bad. But things will be better for it at the end. But before we do that, I just want to know how much autopoly is happening. So here's maybe do autopoly. And how am I going to count this? Because here we make the call. Well, okay, maybe do so we generate this procedure call for that autopoly, which is another thing that we wouldn't have to do, right? We would be able to get rid of all this autopoly stuff. In fact, when we're being the bull in the china shop, the first thing I'm going to do is delete anything with the word autopoly in it and force us to deal, right? Including all this. On that stream the other day, I worked so hard to get all this right, and we're going to delete it because it's going to no longer exist. But that's progress. All right. So here, Oh, force infer structs is probably going to be able to go away eventually. It's going to be so good. Like, that won't be able to go away completely from this refactor, but we'll use it less because we won't use it here. And the fact that we use it less will make it easier to eventually completely remove it. So all these things are going to go. You know, when we were making this game, The Witness, we worked really hard on the design of the game and took the design really deep and ended up with a game that was very complex and pursued its ideas pretty far. And that's not the way most game developers would have done it, right? Most game developers would release version 1 of the game with like basic line drawing puzzles that were mildly interesting, and then maybe in the sequel they do a little more, and then maybe in game 3 we do a little more, right? If they were good, like boring developers would just do this retread of game 1 multiple times, right? And the way I think about The Witness sometimes is that we actually shipped The Witness 3 or The Witness 4, right? Like that's how much internal revision of the original concept we did before we released it. And because we did that, it ended up being a really good game. Whereas if we'd shipped The Witness 1, it might not have been that good, right? So when I do something like this, when I go in and be the bull in the china shop, right, before this compiler has ever been released to anyone, what we're really doing is we're releasing compiler 3 or compiler 4 to the public, right? You're going to get the more mature, more robust thing that is version 3 of this idea, right? You're not going to get crappy, barely working version 1, I hope. So that's another way to think about the philosophy of what we're doing, you know. And that's why I do things this way. Also because I have self-respect, unlike some programmers out there. But you have to be willing to do this, right? Like, so sometimes, especially when people are newer programmers, it's like so hard to get something working that by the time they get it working, they're just like, oh my God, finally. And the last thing they want to do is delete it, or they don't even want to touch it. They don't want to change it at all, right? But you have to fight that, because the way you make things better is by changing them, sometimes drastically. So like last night when I did that profiling, and I did a bunch of code for this fast path for declarations so they could skip all this pipeline in the rest of the compiler. And it added like, I don't know, 60 or 70 lines of code, and de facto made the compiler more complicated because now there's more paths that things could take. And I ran it, and maybe the profiling numbers were microscopically smaller, but not enough to matter. And I was like, you know what? Forget it. We're going to undo this. And I deleted it, right? Now, of course, I realized this morning I didn't check everything I should have checked to make sure that was really working as well as it should. So maybe we'll do it again someday, because that number of how many QUDs we output. So when we do this, right, I turned on this thing, and this number should have gone down by like 3,000 or something. And I didn't check, and it's off the scroll back now. Maybe if I go back in the stream, I can check. But initially this wasn't going down, and it told me that there was a bug. But then when I fixed that, I was convinced that it was working. But maybe it wasn't working as well as it should, and this was still high. So that's also a thing. But it's just to say, you've got to be willing to do that. Your code is not so precious that it should not be deleted. So we're going to delete a lot of stuff today. Is one of my hobbies some form of fighting sports? I did some kung fu training for a few years, and that was good. It had at that time been very far out of the zone of what I had done in life, but it ended up being good. Okay. Now, I want to count the number of polymorphs that are autopoly. I'm going to assume for now that this only causes one polymorph. For all I know, something bananas is going on and it causes more than one. But we're going to assume that this is just one. We're going to go back into main like we did yesterday. We're going to just put this int up here, and that's it. I just want to know this. We already know that our total number is 3,000. Now, the number of autopoly infers, I would guess, is going to be less than half of this, but I don't know how much less than half. I don't know if it's 1,500 or 150 or 15. I don't think it's 15. But it could be 1,500 or 150, and that's a big difference. Autopoly infers 85. That's not that many. So from a performance perspective, the autopoly part is not going to be that big of a deal. That's not the only time, though, that we do this, right? Well, it's going to be, 3 or 4%. And anytime you get in the neighborhood of like 5% of something, that starts to be significant. So 5% of this is, 10% would be like 4.5. So 0.45 milliseconds. That's a reasonable thing to start worrying about. It's not going to have that big of an impact on the entire time, because the entire time is 500 milliseconds, right? It's not even going to take 1 millisecond off that. But you do a bunch of those and they add up. And especially because that 500 is going to go down for other reasons. It's going to go down to like, 250 in single core perf before we parallelize it. So it starts being a bigger amount of that. But the real reason that I'm thinking of this is complexity. I just wanted to know for this. Now, it's not just going to reduce this time, though. Like I said, there's copying that happens. So I want to infer, or I want to and where does that happen? I guess I just go into polymorph. I really want to get rid of this force infer stuff. All right. Where would I insert the profiling? Not there. That's the worst place. Well, can I just do one argument for TM zone like that? Yeah. Let's do copy block. That won't tell us everything, but it'll tell us most. Let's just see what that tells us. I can't do that. All right. Okay, we put 0, 0. All right. Okay. So this is our new profile. And how do I'm forgetting now. All right. Okay. Wait, why was I zoomed in on that? Oh, this is the new one, 10:35 a.m. Duh. I was like, it doesn't look different. Okay, so let's just ask, for example. Oh, and the other thing is that profile I was looking at was just for this. It doesn't include the metaprogram time, which also would have some proportional increase, 15% or something. So copy block. It's not taking that much time. Copying is pretty cheap, which is interesting because I would have thought that a lot of what takes time in polymorph is the copying, but it's totally not. It's like 31 milliseconds internally to the procedure itself. And then half of the rest is copy block, right? And then it's calling, So actually here, this is going to inflate the runtime. I just want to know. We can see if our runtime goes drastically up, we'll know that because it costs a little bit of time to insert these. All right. So we have a new one. That one actually ran faster than either of these. So, okay, we didn't induce too much of a problem. Wait, what? They're not coming out in order. Okay, 10:37 a.m. is this one. Telemetry. Okay, it's sorting by this whole string. So M comes before S in the alphabet, which is why these are before that, but then this time is later than that time. Yeah, I wish they would fix that. Okay. Copy. Copy expression. 62 milliseconds. So for some reason, copy block didn't include that time. And we know that that's not mostly overhead because our time, well, maybe. I mean, this is higher than this by 30 milliseconds. So a lot of that could be overhead. It's just our earlier run was also 1.15 seconds. So, this is just the vagary of profiling. Once what are all these things? Which one was it? Is it this one? Has copy. Yeah, I mean, once you're calling something 218,000 times, you have to start to assume that some amount of this time is overhead. Yeah. So anyway, in the near term, then what these numbers mean is we'll get a little bit of a performance boost probably from doing this, but really the reason we're doing it is mostly complexity reduction. And that's just a good thing to understand going into it, right? It sets our expectations. Final QS equals 39 at the end of the last VOD. Is that at the end after I deleted the optimization or before I deleted the optimization? Because we don't want the very end. At the very end, I tested that it still worked after I deleted the optimization, right? So we want the one before that, when I was looking, or some amount of time before that. Okay. Yeah, I always, before I check in, I always run to test. So, um, are there questions about any of this that we've just been saying? I'm going to get a small snack, and then it's time to start being a bull in the china shop. And won't that be fun? Would I ever revert a less complex, clearer code structure that I am more happy with when it turns out to make performance worse? It depends on how much worse and how much simpler. It's a trade-off, right? So if your thing is so complicated, and it depends on where in development you are. If you're still early in the middle of development, then more complicated code, even if it looks faster, is bad for development because it affects your ability to work on and understand the system. And if you don't understand the system well, you're going to do things wrong that cost time, or you're going to be spending time in places where you shouldn't be spending it, but you're not going to notice that because your understanding, your ability to see that is bottlenecked by, or is clouded by the complicated things. So you're actually going to end up making a slower program than you should just because of your inability to see the things that are slow or that they're needlessly slow. That's actually one reason why so much modern software is slow. It's because it's complicated and people don't understand what they're programming. So I just have to say it depends. There are definitely cases when I would delete that code, and there are definitely cases when I wouldn't. What do I like about telemetry over WPA? What is WPA? Windows Performance Analyzer. I haven't tried to use it. I just don't have much faith in Microsoft software when it comes to performance analysis. Is that the thing that ships in Visual Studio that has a 1 millisecond granularity? That's awful. What am I going to do with a 1 millisecond granularity profiler? Like this thing lets me zoom down. Look, 11 microseconds. Like I can see that, right? This is telemetry from Rad Games Tools. Okay, short break. Please address, we just had a big information dump, so please address questions to me or go to Choco Taco's channel and watch PUBG. I'll be back in a minute. I'm going to get some snacks. When I criticize PUBG, do I criticize their developers' code quality or Unreal Engine? I'm not criticizing either. I'm criticizing the fact that the game runs very poorly and they haven't fixed some of the most basic problems after a year of public release. And they grew their team and they used some of that extra manpower to make other versions of the game on other platforms and to make loot boxes instead of like fixing their basic problems. Okay, back in a second. Man, I need some kind of some kind of cough drops or something because my throat is getting hoarse from all this talking that I've been doing for the past few days. I need to learn to speak in a more relaxed manner. But during the break, during whatever the first break is today, I'm probably going to go out and get something like that. I think you said you only have print instead of print. In print line, does print auto flush? Probably. I don't remember. I'm not that worried about it because the levels of abstraction that C chose for print, like what happens when, are not really correct for modern programming. Like having this layer of abstraction that doesn't auto flush just causes problems. Like if you want to be fast, actually, then you'll explicitly build a buffer in memory and then blast it out to a file at once, right? This whole thing where you printf but it doesn't go out until you flush is not really fast, and it also causes bugs. So I would not really choose to do things that way. Okay, I'm gonna get this tea and I will be back in a second. It was 398XX before the revert. Okay, well, maybe that means I have to go back and retry that optimization. I did save the pieces in a file. Because if it is 398XX, that means that stuff was still getting queued. It just maybe was getting queued a little bit later. So retry fast track. However, we're not going to be able to do that for a while because we're about to completely destroy everything here. Okay, let me get that tea. Water's done boiling. With the witness released being the witness 4, did you get everything in you wanted? Yes, absolutely. Absolutely. Ginger Bill, you're saying parallelization of your type checker is slower? Or do you mean this one? This type checker is not parallelized right now. I want to eventually, but it's a little bit scary because it's the most complicated part of the code, and C++ doesn't give you very many tools for not making your parallel code buggy. So there's that. Your type checker is slower. Yeah, I mean, often if code is complicated and you try to parallelize it, it'll often be slower at first because, taking mutexes, for example, has overhead. And if you're always waiting on somebody else, then you're not getting any parallelism. So it's not that surprising. It's not that easy to make code that parallelizes effectively. The number one thing to do is to figure out how to compartmentalize being able to do a large amount of work without getting data from somebody else. If you can do that, then it'll parallelize well. Have I ever tried my hand at embedded software, or is that outside my interest area? I've never tried it. I'm not uninterested in it, but I just have a lot to do right now, and I'm not exactly picking up alternate software projects. You know, there's a smudge on this camera that's kind of bugging me. So I'm going to try busting out the lens wipes, and we'll see if I can improve the picture quality. Chances are I make it drastically worse for a second because it'll be all wet. So we'll see. And instead of using a lens cleaning towel, I am going to use, well, the wipe is a lens towelette, but then I'm going to use a t-shirt to dry it off, so that's always a good idea. All right. Whoop, whoop, whoop. It's just, you know, you want your optic surface to be clear. If you have seizures easily, don't look in the corner of the screen. Okay. Probably will not look any different in practice. But I'd rather not have that distraction of looking up there and wondering. It's like the profiling, you know? I just want to know. I want to know how much it matters. I don't see any difference at all. Is that what ASMR people do, is make weird scrubbing noises into the microphone? I don't exactly know how that goes. Could I give you an idea of the price of a telemetry license for a solo developer? Would you consider it something worth the money? I don't know how much solo developers would pay. I don't know what RAD's pricing policy is. You could just ask them. They have an email address where you can email and ask. I know it's worth it for our company. I don't remember how much we pay. I don't want to get this wrong, but I think it's, I don't want to say and get it wrong, but it's not that expensive for us. You know, when you consider that it's a company-wide license, we basically pay per game per platform. So for one game, and one platform, we pay a certain amount per year. But you know, the deal you get is like whatever RAD wants. So if they want to increase adoption of this among solo developers, then they might have a pricing strategy where they give you a real good break on it. I don't know. I don't know. Maybe they don't. Maybe they figure they want to minimize their support hassles and only want to license it to people who want to pay a lot. That's just one of the tactics that you choose when you're running a business, is where you want to come down on that spectrum. They make weird noises and some people get a tingling sensation from it. All right, well, that's not really what this stream is about. Can you tell Jeff to give out discounts to your stream viewers? Well, I could tell him that, but I don't know if that would do anything. Right now, working from home. We have an office, but I am not there. Today's a holiday. It's an official holiday in the U.S. So I'm not in the office. Okay. Well, we're going to close this profiler telemetry by Rad Game Tools because we're not working on. I mean, we'll get some speed benefit out of this. But again, the main speed benefit, so going back to what I was saying a second ago, the main speed benefit that we're going to get ultimately is that hopefully, if this change of this core structure, the way polymorphism works, if it doesn't go badly, it should end up being a lot simpler than uh, than what we have now. And simpler systems are easier to optimize by far, right? So if we want to be fast, then making something simple faster is, all other things being equal, is easier than making something complicated faster. Now, when you make things faster, you do go from simpler to more complicated also, right? So simple things tend to be slower than more complicated things if the complication was introduced as part of an optimization, right? But actually also, if the complication wasn't introduced as part of an optimization, complicated things tend to be slower than simpler things because complicated things have more code, and when you're running more code, you're just taking more time. Bob Ross is considered to be one of the first ASMR artists, although he didn't know it at the time. Okay. That's an interesting fact that I didn't know. It's always weird to me the way they say bank holiday in England. That every time I go to England, that freaks me out. Like bank holiday is what we would just call a holiday in the US. Whereas in England, I think they say that to differentiate it from going on holiday, which is just like when you travel somewhere. But like bank holiday makes it sound like everybody cares a lot about banks, which is a weird thing to me. It's off-putting. It's off-putting. Data is so serial, parallelizing was a stupid idea. Yeah, but we don't, we don't in the US think about holidays in terms of banks being closed or open. It's just not how we do it, right? We just don't care whether banks are closed or open that much. It's not an issue for us. All right, I forgot to get food snack. Back in a second, and then we will actually start. Oh, and also, just for entertainment value, let's see how many lines of code we are before and after wrecking all this stuff. So I'm going to get a new notebook page, and I'm going to say, I just tore that page. Screw that page. We didn't want it anyway. Okay. We are at 41568 before big deletions. Okay. Back in a sec. I've been streaming during the day all weekend. It's been a mega stream weekend. Yeah, so this 41,000 lines does not count blank or comment lines, right? This is just actual code lines. Single close braces count as code lines, though. There's 12,000 blank lines and 8,500 comment lines. Would I say this is a more dense code base than typical? No. Well, what I would say is that the styles that some people have of programming, and especially object-oriented programming, encourages really a lot more bloat than is needed. And again, like I was just saying, that makes things slower, first of all. Also, the memory access patterns you have with object-oriented code are a lot slower. But also just, there's been a lot of bad advice given to people, not even just object-orientedism, but in general, the advice that is given to people about how to program is quite often bad and leads you to have much more code than you need. And then the problem is, the more code you have, the harder things are to understand and the harder things are to accomplish, right? Not only because you have to type in and maintain all that code, but because at some point things go beyond your threshold of what you can easily manipulate and maintain, right? So it's a weird thing because when people give you advice about how to program, if you're absolutely new and you don't know anything and you need a place to start, that advice is maybe good. But once you have a basic idea, a lot of that advice is just really bad and pointing you in the wrong direction, which is why I can't recommend programming books to anybody, because I think most of them are pretty terrible, honestly. Maybe I should count semicolons instead of non-blank lines. Maybe. I mean, this is somebody else's program that I'm using, right? So I'm just using their off-the-shelf C++ line counter program. So figuring out how to modify its idea of what counts as a line, I could probably do, but it's more of an investment than I want to make. Have I ever played Twilight Struggle? No, never heard of it. Zen Chaotic Neutral is asking, so your main concern is threading the needle between complexity and performance. Is that why you have such a aversion to the phrase reinventing the wheel? No. So first of all, I would say yes, it's a big concern to thread the needle between complexity and importance in early to middle stages of development. In later stages of development, once your thing is locked down and you really want performance, then you're necessarily increasing complexity also. Optimization, the serious kind of optimization, you're increasing complexity. That's just how it is. I mean, there are exceptions to that, but yes, you're generally increasing complexity and increasing performance. So the thing I was saying before about managing complexity so that you understand your system and see where the speed goes is really for early and middle development. I mean, you want to do that always, but it's the dominant factor in early and middle development. Late development, the dominant factor is just how much work you put in to make it fast. How does GCC have 7 million lines of code? Well, GCC supports a lot of programming languages. And it has an optimizer, whereas this doesn't have an optimizer. But also, yes, GCC is just terribly bloated and slow. Like, there's no question about that. It does, well, it quote unquote does more than this compiler, but this language already has way more features than C++, right? Like, our polymorphism is better than C++. Our metaprogramming is way better. blah, right? Which is not to say we can do everything that C++ compilers can do. So we don't have intrinsics yet. We don't have inline assembly yet. There's probably some features from the C++ language itself that we don't have an equivalent of yet that we would like to have. So this is not saying that we're absolutely a superset of C++ at this time, but we do some stuff that's just way better. You know, the compile time execution engine is just way better than anything C++ will give you. So, you know, it's not exactly an apples to apples comparison. But yeah, there's no, like once you have a compiler and it's 7 million lines, apply everything Casey said from his 30 million lines of code lecture about how that's a terrible disaster. Yes, it's a terrible disaster to have your compiler be 7 million lines because it means nobody has any idea what's actually happening in there. And how are you going to do good work when nobody has any idea what's happening? Do I ever use linked lists? Yes. My most common data structure is an auto-resizable array, but sometimes a linked list is a better access pattern. For example, when you don't want the memory to move because somebody wants to be able to take a pointer to something, or when it's a queue, like if you're not going to be searching the list for items out of the middle, if you're just going to add stuff and then pop stuff off, then a linked list is fine, right? It all depends. But yeah, I don't use them very often. I usually use arrays. Can I please give an example to these bad advices? Well, the classic example from the old days, you don't hear it so often anymore, but there's this example, you know, from object-oriented programming that you should never access a member variable. You should have getters and setters for everything because you have to have this layer of insulation so that you're allowed to change implementation details and people just access the interface. That's some of the worst advice ever given, and many, many, many programmers learned how to program that way. It's terrible advice because it leads to way too much code. It makes your code slower. It makes your compile time much higher. And it doesn't even work because like non-trivial changes to functionality require a different interface. So it's not like you could even use the old trivial getter for your variable anymore, right? It's just bad advice by people who didn't really know how to program well enough to give advice. You know, there's modern, like when you, like the other day I was looking on Hacker News and people were talking about design patterns, and there's all these patterns, right, that are good or bad, like quote good or quote bad, like the don't repeat yourself and the single responsibility principle or whatever, right? And those things are, in reality, ideas that you should have in your head somewhere about what are kind of good, but you shouldn't program in a way where you're trying to comply with those all the time, because that's wrong. Like both me and Casey, in fact, program often by just pasting stuff and changing it and then later cleaning it up. We're repeating ourselves as soon as we paste it, right? So we're violating the so-called don't repeat yourself principle. But there's good reasons to do that. And I don't want to go too much into it right now because this isn't a coding philosophy stream today. But, you know, following that advice usually ends up bad. It usually is a net loss for people. Unless they don't have any idea about how to program, and then saying don't repeat yourself or single responsibility principle will help communicate to people what good code is like. And that's good. However, it's very easily taken way too far and results in a horrible trash pile. People all the time ask me how to learn to program, and I don't know what to say. Just try some stuff. Do I do my resizable arrays with realloc or something more sophisticated? No, something less sophisticated. So the dirty secret of realloc is it's stupid because it's probably not going to be able to reuse the same memory. So you might as well just allocate new memory and copy it. So there's that, first of all. Second of all, you don't really want to be using the general heap if you can avoid it. I mean, if you don't know how your array is going to be used, then do that, fine. But in this compiler, we use custom memory arenas that are just linear allocators for most of that stuff. So when I reallocate an array, that's just a few lines of code where the linear allocator bumps its thing forward, and then we copy into the new memory, and then we don't free the old memory because we just let it leak until a later time, such as when that module of the compiler shuts down, then that memory goes away. It's tremendously faster than using malloc. How much do I care about alignment in allocators? Well, it's not how much I care. It's it's that you have to align things or else your program will crash. So there's that. By default on a modern processor, you had better align things to 8 bytes or the program will crash. Some things need more specific alignment than that, but what I think is that in those cases, the author of the program needs to request that alignment because they know what it needs to be. So for example, if something is going to get DMA'd and the DMA controller requires things to be 128 byte aligned or something, then that needs to be that way. Or certain SIMD instructions, I think, can only load from certain very broad alignments. And so if you're going to store something that's of one of those SIMD data types, then the alignment of the structure needs to be set, and et cetera. What do I think of test-driven development? I think it's a horrible trash pile. I'm sure someone can point you to a good rant on YouTube, but the reason TDD happened is because people were using awful programming languages like JavaScript where you're afraid to refactor because you'll just break everything, right? In a strongly typed language, even a relatively bad one like C++, you don't have that problem. So almost everything that TDD is focused on is stupid when you use a real programming language. That's why TDD didn't come from the 1970s or 1980s or 1990s, because we were all using better programming languages during those decades than all these people using JavaScript today. Did I ever decide if I want it to 0 stack allocated structures by default? That is how things work by default right now. I'm not sure that that's the best choice in the long term, but a lot of the time it makes your program less verbose, and so I opted for that. We'll see if that's a good idea. Might be better to say unrepeat yourself. Yeah, maybe. What principles do I use to organize code between CPP and H files? At this point, I don't care very much because header files in C++ are basically a giant disaster that wastes programmer time and makes your compile slow. In the new language, there's no header files. So I have great contempt for header files now, and I just do whatever. I don't try to keep them that organized because I'm trying to get off C++. So I just don't care about all that garbage at this point. Is the syntax finalized? No. Tell us something about procrastination. I don't know. Why won't we have smart pointers? You can make a smart pointer probably if you want. It's just we don't support it. And I mean, I need to make a YouTube rant because I'm sure I talk about smart pointers in great detail somewhere. I talked about C# on the last stream, so we won't do that again. You can look at the VOD from last night. Someone is mentioning Pear's series where he does stuff from a very low level. I haven't watched it yet, but I've heard it's good. So yeah, go ahead and follow that link. Somebody linked to an 8-minute rant about unit testing in TDD, so you can watch that if you want to get offended by my opinion about test-driven development. Did I have to do any SIMD optimization to Braid or the witness? Yes, in both. Yeah, sorry, this ended up a long talk session. We'll do some programming in a second. Any plans to release games on the Nintendo Switch? Maybe, I don't know. Any idea what needs to be done? Well, it's like targeting any console where they have their own API that you have to use, and the hardware works in a slightly different way than some other console. It's definitely a task to do that. Okay. Would we ever license the witness tech to third-party game studios? Maybe, but I think if somebody wants to license an engine, they probably want an engine made for customers, which is what Unity and Unreal are. Our engine is not made for customers, and we don't want to spend a lot of time being in the engine support business. So it's not super likely that we would do that, but I could imagine some weird situation in which we would. Have I ever looked at VHDL and Verilog? Yeah, I saw a little bit of those in college, and they did look pretty terrible. Okay, let's get to the programming. Let's get to the programming. Or the unprogramming, as the case may be, because we're about to be a bull in the china shop. We're about to wreck the program. It's unlikely that it will be back in working condition by the end of today. And in fact, it's quite possible that this entire thing I'm about to do is a mistake and will eventually revert it. But if that's true, we will have learned something. So sometimes I get a big idea about how I'm going to make something better, and then I go start to do it. And in the process of doing it, I remember this complicated corner case and that complicated thing that I don't usually think about, but that has to be there to support some other feature. And I eventually realized that the way that I wanted to do it won't work really because of X, Y, and Z, and then I have to revert. So this might be one of those. But if that's the case, then I'll just write a big comment about why it can't be done this way, and then that will be progress in understanding that we can use for next time. But first, we're going to delete some things. Commodore 64 user out there. Yeah. Yeah, okay. Okay, so let's delete some things. So we're at 41568 lines of code. I want to delete everything having to do with autopoly and everything about having to do with stealing polymorphism. And then we're just going to make things compile. It won't work on anything polymorphic, but maybe we'll make sure the compiler works on anything non-polymorphic. Although, does the preload have polymorphism? Yes. So calling any of these things won't work. Oh, type infocast. I don't think we need this anymore. I'm going to write on my to-do list, type infocast in preload. I think we can delete this. And deleting stuff from the preload is good because this file has to load up before anyone can do anything in the compiler. So we want it to be as small as possible. Okay. All right, so autopoly. Boom, look at all this. Let's just delete that. And that, we're just not going to have any such thing as autopoly. We're going to delete that. We're going to delete that. That just copies the slot. So we have to be careful. We can't delete any block that says autopoly because sometimes if something says if not autopoly, we have to keep the block and just delete the conditional, right? So anyway, that, well, we'll get rid of that. And that. Oh, it's so much fun deleting code. Delete that comment. Okay, here is if not, and you know what? I can't frickin' edit in Visual Studio to save my life. I hate it, so I'm not even going to try. I'm going to leave this one for later, and then we're going to go to Emacs. Make unique polymorph variable. This whole thing goes away. Maybe do auto poly. This whole thing goes. Did you see that frickin' garbage collection stall right there? All I'm doing is deleting lines of text. That shouldn't happen. Okay. This should not happen. I did it again. It's like, why? It just makes something where I can edit code. Now, you know what? We're not going to need to put anything there, I hope. All right. Let's just, I'm going to kick off a compile to save all the buffers. We're not expecting it to actually compile right now. I did an explanation of what autopoly was at the start of this stream, so you can go back. The first 40 minutes of this stream was a big explanation of like the polymorphism and what all the different elements of it are. So you can go back and watch that later maybe. Okay, so we saved all our buffers. Let's search for autopoly. Thank you, Visual Studio, for erasing what I searched. Oh, we got most of it. So we'll get rid of that. We'll get rid of that. So then the last thing is in polymorph.cpp. Autopoly. So if we're not autopoly, we do this. And that's fine. Okay. Now, we're still not, no, maybe we will compile. Maybe we will compile. Okay. So now we should work on anything that doesn't require autopoly. But now let's go one step further. Let's look for steel. That's not the right steel. Concatenator steel is not. We don't call it steel anymore. Steel queuing. That comment is old because we're not stealing polymorphism here. Maybe we don't steal in the same way. Oh, here we go. When we put an argument into a procedure, we see if it's a polymorphic procedure. And if so, we, put those identifiers into our constants block and so forth. Now, before I delete this, I want to think about what is actually going to happen. I've got a lambda with a header, and it's got a procedure that's an argument. And that argument defines a polymorph variable. Then we'll have an identifier on there, flagged ident defines polymorph variable. And that lambda will have an inferred type. There's this whole type definition hack. That's another thing that I would like to simplify later, but it's a separate thing. So the inferred type of that polymorphic parameter would say defines polymorph variable just like it does now. So the difference is just we don't lift things up into our constants block. We let it have its own constants block. And if that's a bad idea, then I'm going to be sorry that I deleted this. Well, let's kick off a build again to compile that. Why am I not using vassistx? Because I edit in Emacs usually. I don't use Visual Studio as an editor usually. I hate it. I use it in these rare cases, you know, when I can do the full project search and click on individual lines, but usually I don't try to edit. The experience of editing in Visual Studio is so awful. And they think they keep making it better by adding more stuff. It is so terrible that I just don't want anything to do with it. Okay. Well, we compile. So that's something. Let's compile the non-telemetry build because we've been there for a while. Let's see how much code we got rid of. This is probably not nearly all the code that we will get to get rid of. It's just those are the obvious things that I can think of to delete. So we're now at 41451. So it's not even that much code. It's 117 lines. 41451 after steal and autopoly deletion. However, the way polymorphing happens will hopefully get simpler too. So the line count should go down even a little further. We'll see. I have a feeling we're going to delete a lot more stuff. I just don't know what it is offhand yet. Have I tried Visual Studio Code? No. I don't want to use an editor that's written in frickin' JavaScript or whatever. Didn't someone measure the latency of key presses in Visual Studio Code and it's like 150 milliseconds or something absurd like that? Yeah, get that out of my face. Well, somebody did a comparison between all these editors about what the latency was. As a replacement for Visual Studio. So my current plan, just because people keep asking this, I'm not that interested in making my Visual Studio experience better because I don't want to have a Visual Studio experience. The reason I'm making a new language is because this whole paradigm of how all this stuff is done, I think is bad. And I don't want to have that experience at all. I want to have a compiler that's simple and doesn't require this massive, bloated, badly working tool chain, right? So I'm not interested in making Visual Studio better for me because I want my life to consist of 0% Visual Studio usage. Now, of course, I have to use it some right now because I'm debugging a C++ program. Eventually, I won't be programming in C++ at all anymore, right? And so forth. Do you think there should be a built-in compiler feature that outputs function signatures from a given file, sort of like auto-generated header file. Yeah, you could do that pretty trivially, actually, with metaprogramming right now in the new language. In fact, we have a metaprogram that just prints out your whole program again. So you could easily reduce that to just printing out headers for procedures. Simple. Do I think VS compiler for C++ is that bad? What's VS compiler? Have I tried the Kinesis Advantage 2 keyboard? I tried it a long time ago. I didn't ultimately like it that much. How about Sublime Text? Sublime, no. If I switch to something, it'll probably be 4-coder. But again, that requires more work from me than I want to put in right now. Have I settled on a new laptop for development? I ordered an Alienware 15, the new version. It should arrive any day, and then I'll see how much I should regret having ordered that Alienware 15. Did I know Alan is now at RAD? I think I heard that somewhere, but I didn't know it for sure. That's good. Makes me wish we'd hired him, but I don't always jump on the ball like that. But Rad pays a lot of money, so good for him. It's so stupid. I should have hired him because I hired Abner, and that seemed like a smart thing at the time. Should have gone a little further than that. All right. All right. Well, I mean, we're a small company, so even hiring one extra person seems like a big step. So hiring 2 people seems like a much bigger step. But it's important to hire the younger people who are taking initiative and doing interesting things because there's not very many of those people. Okay, so now what I'm going to do is I'm going to verify that we still have a compiler, right? So let's just go into compiler bugs, bug 140, 174, whatever the last one was. I'm just going to use this as a folder, right? Like here was a program. Oh, this had polymorphic stuff in it. Let's just make a test here. Let's not import print. Print probably, well, does print have polymorphic stuff? There's no $signs in print. That's good. How about string builder? Yes, but there's probably no steals. So let's see if we can use print. Import print main print hello sailor. Okay, so that compiles Sokoban, and that is failing in polymorphism, so we expect that. That's totally fine. But I want to see if we can do simpler. Oh, wait. Was my other shell already there? Yes, but this is the one that's attempting to index a null value because frickin' Commander is high quality Lua software. So we're going to exit that shell, and we're going to do the one that doesn't say that every frame. Now, let's do that. Hello, Sailor. Okay, so basic programs still work despite the fact that I deleted stuff. And in fact, I should be able to do simple polymorphism. So I should be able to do like fusel is x of $T print the type of x is whatever and its value is whatever. X, or no, tx, right? Print fusel of A, no, not, just fusel of A, fusel of main, right? So, oh, right. This won't work because fusel is polymorphic, and polymorphic arguments are not going to work until, yeah. Oh, no, that's not even, this is just that there's no resolved type ultimately, because we said it's of some type, and that type it has of some type, so it's, that would never work actually. Hey, look, we attempting to index a null value again. Fucking, it's been doing that for like the whole time I've been using Commander. For years it's been doing this garbage, and they never fix it. Like when you can't even make a command shell, just question the way you're programming. Like, yeah. Okay. So that's the Sokoban one. I'm just doing that so I can get the executable. And there we go. Okay, test. Okay. Type of X is S64 and its value is 0. Type of X is some type and its value is procedure, blah, blah, blah. This is just that print doesn't go through the effort of printing out a procedure type right now. We could, but it's like, right? So this is all working as expected. So basic polymorphism works. That's great. What's not going to work is stealing things. So now let's make an example of something that is not going to work. Why Commander and not conmu? I don't know, because people said try Commander. Conmu sounds like a pack animal. Like, I don't know what that is. I don't want an emulator. I want a console. Okay. You could switch WSL. You can run .exe there from still have bash. Yeah, I mean, I just don't want to complicate my life that much. Yeah, okay. So something that's not going to work is the following. Apply X takes arg of some type and yields an int, no, a string, comma, y is a t, and we're going to say s is x of y, print s is blah s, right? So so then I want to apply something. I'm going to apply type namer to, wait. Let's make it not polymorphic because we're going to keep it simpler. So we're going to pass an int. So we're going to pass a. We're going to take a. We're just going to make it be factorial as string or something stupid. I made this a string, so whatever. Let's just. Yeah. Okay. This is not a string. So we're just going to say factorial, right? Factorial okay, you better not pass a negative number in there. So so we're going to apply factorial to A. So factorial will match to here. It should assign t to int, and then know that y is int, and then verify that that matches that. However, that won't work yet, because we just deleted all the stuff that makes that work. And we're going to do it a different way. So this just shouldn't even compile right now. Okay. That's a really weird error to get. Oh, well, it's because I did the wrong thing. Sorry. Polymorphic procedure must have a body. Okay, so the reason it's saying this is because, you know, we didn't like steal the polymorphism out of this. So I think this is where I'm going to take a break on this first stream, and I'm maybe going to go get some cough drops, and walk around a little bit, and then I'll come back, you know, in an hour or two, and we will start making this work the new way. Any on-topic final questions before I go doing that? This is a good cliffhanger, right? If you're making a TV show like Lost, you want to end the episode on a cliffhanger so nobody knows what's going to happen next. And here we go. We deleted this stuff that makes polymorphism work. And it's like, but what's going to happen? What's going to happen? Well, you'll find out in the next episode. Well, the current compile time for Sokoban we cannot test because it will not compile, right? It's going to error until we fix this. So we don't know. The current count we do know. Whoops. Here. The current count is 41451. So that is, you know, 120 lines down or something from before we deleted things. So we only deleted 120 lines of code, which is less than I expected. But like I said, I think there's lots of latent complications spread throughout the system that we're also going to be deleting. So I don't know what the total amount of deleted code will be. Is the autopoly thing you were talking about the case where you pass a poly function as an argument and have it be instantiated? No. Autopoly is when you have a struct that's polymorphic and you don't want to have to say it's polymorphic. Like, you can put it in the argument list for a procedure and it looks just like a regular struct. But because we know it's polymorphic, then, you know, we supply the arguments. That's what that was. Okay. Thanks everybody for stopping by. I'm taking a break. I'll be back later. Have fun. Go watch Choco Taco or wait, who the GeoHot guy, I guess, is streaming. Is that true? I don't know if someone was just saying that. Maybe Handmade Hero is happening soon, right? I think Handmade Hero might be starting at 12. Let me, I want to see if there's other programming. How do I find creative here? If there's another programmer, I can host them. Where's frickin' creative? I just can't even find it. There's not that many creative people. If I type creative in the search bar, there we go. Bob Ross Marathon. Then this. We're number 2 in creative. Bob Ross is 3 times as many people. Lots of people drawing. I don't see any programming. So that's, maybe people are using the programming channel. There's just a lot of visual art happening in creative. Let me put this over here so people could see. Does anyone see any programming here? Sculpting, that's cool. Dog laying there. Okay. We're down to like 5 viewers type of situation. So let's see if we can find programming. Oh, there's people on this channel. Everyone was telling me all the programming happens on creative, but most of the programming is happening on programming right now. Answering questions about C# and .NET. I'm not going to host that. God, no. Learning Python, maybe. Unity 2D game dev. Day 29, Pirate MMO. Well, he doesn't seem to be interacting and saying very much. WordPress Linux LAMP, no way in hell am I hosting that. Symphony personal project. What is this with people cranking music? They don't want to talk about what they're doing? Computer science programming. Well, he's using templates. That's a disaster. Creating a CMS in Java, Python web app, basic Java. Oh my God, look at all that. Look at all those templates right there. Holy crap. Okay. Well, I'm going to host Qt creator guy, even though he uses templates. Wait, Tom Cruise 3? Who is that? Tom. Oh, yeah. Okay. That's an interesting topic. Okay, let's host that guy. What category is he streaming in? Host Tom Cruise 3. And I'll delay for a second. Oh, I already decided to host Slam Guy. So we'll host Ginger Bill next time. See you guys later.